नन्दन रघुरघुनन्दन रघुवर सेवन रघुपति चायन.
Hello engineers, welcome to the Civil Tales. Today our topic is the strength of materials, part 1. Starting our topic with a quote that is, all of our dreams can come true if we have the courage to pursue them. So in an easy language we can say that dreams don't come true just by wishing. We must have the courage to face the challenges. We must have the courage to overcome the obstacles and keep moving forward. If we stay determined and never give up to our dreams, to our goals, we can turn our dreams into the reality. Take it in a mind, put it in a mind, and start our topic. Okay, na? So, what is load? The load is the external force which applied to the structural element or material. So, in an easy language, we can say that it is an external force that affects the structure, influencing its stability, durability, and performance. So, there are four types of loads: tensile load, compressive load, shear load, and torsion load. In our upcoming slide, we will discuss this in a descriptive mode and take the example that tensile load. We can say that the rope and cables in suspension bridge. Okay, compressive load, the columns and bridge, columns and beams of of our building. Shear load, we can say, in is a scissor cutting paper. And torsion load, that drives shafts in vehicle. Okay, so what is dead load? Starting our classification of loads, what is dead load? So dead load is, it is the weight of structural permanent parts which don't move, which will be remain constant over time. So in this for picture, we can say that this is our dead load. This is the permanent parts of our building. This is dead load. This is dead load. Okay, this also we can say as a dead load. Okay, means the main structure. Okay, the itself load is a dead load. Another load is live load. So we can say that a temporary or moving force that a structure experiencing during its use, and this is also known as the imposed load. So in many questions, they are asking that what is imposed load. We have you have to say that the imposed load nothing but the live load. So we can say with an example that the people of the house, the people, the furniture of the house, and the vehicles, it is the live load which is not constant, which is movable. Okay, these loads are live load. So inertial load or force, or centrifugal load or force. So what is inertial load? It is the force opposite in direction to an accelerating force acting on a body and equal to the product of the accelerating force and the mass of the body. So you can see, you can see in the picture that if this motor working in a clockwise, this load, it will be in anti-clockwise. So this is the example of an inertia force. Okay na? And keep in mind that inertia increases with the increase in the mass of the body, and it is also the vice versa. So inertia increase with the increase of the mass of the body. Okay, means if the mass of the body increase, the inertia will be increase, and it is the vice versa. दोनों में कोई भी हो सकता है. Okay, so what is centrifugal force? Centrifugal force is the frictional force, and it is also the circular motion which acts along the radius, and it directed away from the center of the circle. Like in a spinning, if someone is spinning this ball, okay, so this is acting, means the centrifugal force towards the radius, and the object will be applying force in the dia, okay. Also that car turning the car in the circular rotation, so also it will be acting the in the radius, and the center of force, the dia he will travel, okay. Also we can say the roller coaster, and the sun, the earth moving around the sun, it also the example of centrifugal force. Coming to the next, what is tensile load, compressive load, bending load, shear load, and torsion load? So these are the descriptive. Okay, if we taking this photo, and you people just pause it, and you people just read. I am taking, means just describe in this photo. Okay. So what is tensile load? A tensile load is a force that pulls or stretches the material, trying to make it longer. So here you can say this way the force is acting, also this way the force is acting. Okay. So this that load in this body, it will acts as a tensile load, tension. Okay. So compressive load, what is the? It is the opposite of the tensile load. A compressive load is it is the force that pushes or squeezes a material, trying to make it shorter, and it tests the material ability to resist crushing or bulking. Crushing or bulking test, at the crushing or bulking test, you also note that the machine called UTM, Universal Testing Machine, also it will squeezes towards the vertically, and this load is called as tensile load, compressive load, sorry. So example, squeezing in a rubber ball in your hand, and the example of the tension is it helps, means sorry, it helps to resist the material ability to resist breaking the under tension. What is bending? Bending load, it is the load that causes material to curve or bend inside the staying straight. Means if the force we are acting force this way, also we will acting force this way. Okay. So it will be not stay in a straight line. It will be something tilt this way, because the force is much in this way. It will be tilt like that. Okay, so this is the load which creates both tension and compression with the material, because when we'll putting force in this way here, uh, means just uh, we will taking one of the force, also there we will taking one of the force. So this is the force, and this is the load where tensile and compressive load will act in a same way. What is shear load? It is the load that causes parts of the material to slide past each other in opposite direction. Like uh, if we taking in a half way, first part you are giving load this way, and second part you are giving load this way. So here the braking will be start. Okay. So this is the shear load. Okay. And what is torsion? Torsion, you can say that the load is a force that twists the material around its axis. It creates shear stress and can cause the material to rotate or break. So you can say that we will putting load in a in this angle, and also we will putting load this angle. So here also we can show the see the breakage. Okay. So this load is called as torsion load. The most important load is the point load. A load acting at the point of a beam is called as point load or concentrated load. So when a load is acting at a point of beam, it is known as a point load. So you that this is a beam, okay, and this W is a load. So here it it is giving the point load, okay. In upcoming series, we'll see that FFD, BMD, free body diagram. In there also the point load is a most important thing. This
Also
is
the
our point load, okay now. So next is our uniformly distribution load, UDL. So it is the load that spread evenly over the surface or length of the beam. And also it is to be noted that the load is applied the same force per unit length or area, ensuring the uniformly straight and distribution. As you can see that here is a support and also here is a support, but the this is the this is our beam, okay. So over all the beams there are uniformly loaded is applying, so this is called as a UDL or uniformly distributed load. This load is means uh, same, this load is constant to all over the beam, all over the part, unlike the point load. This is acting in a single point, but this is acting to all of the part of the beam, okay. This also is a very important uniformly variable load. So this is the load that changes gradually along the length of the beam or surface. It can increase or decrease it in intensity and forming a triangular or trapezoidal distribution. So here you can see there is a support and there is a support. So this is our beam and this also is our beam. Here what happening? Here in the starting we are means taking a small amount of load, and at the time of we are seeing this the load is increasing. It is an increasing order. So here we are taking the shape is a trapezoidal shape, and here the point means this middle the force is much, and the both of the side this is small number of force, small number of load. So this is triangular load. Triangular means it is forming triangular shape, triangular shape, and this is trapezoidal, trapezoidal, okay. Now what is stress? The stress is the internal force per unit area within a material with the subjected to the external load. It determines how much can withstand before deformation or failure, okay. So there are not the two types of stress. One is normal stress and another is shear stress, okay. We can divide it in two parts, okay. One is normal stress, another is shear stress, and the symbol it is normal stress. We are talking about force by area, applied force by area. So it is you have to see that this is the force is applying to the vertically, okay, and the shear force we are taking in horizontally. So this is the means applied force by cross sectional area, okay. And what is bearing stress? Bearing stress is the constant pressure between two materials when one presses against another. If we considering the image, the stress occurs when the materials reach to the compressive force or another material at the area of contact. It typically happens in situational when compounds like bolts, pins, or other supports bear against each other. So when a force acting in this way, another force is acting this way. Here we will see some stress. Here we will see some means accent. It is called the bearing stress. Okay. Also, you can see in this animation that when in a this is a bolt. Okay, this is a bolt. The load is applying this way, so you can see there is the stress. This part is the stress. Okay, so here we'll understand the resistance uh, permeabilities that helps in designing materials to endure stress. Now we'll talking about the yield strength. So this is the point, yield strength. This is the point. Okay, where the plastic limit going to the uh, b- elastic limit going to the plastic limit. Okay, so this part is elastic limit and this part is plastic limit. So this is the stress at which a material begin to deform plasticity. Okay, as we talked that it is the point to elastic limit to plastic limit. Okay, it will be the part to elastic limit to plastic limit. And what is UTS? Ultimate tensile strength. This is the maximum stress a material can endure before failure. Okay, so this is the ultimate strength. Okay, this point. So this is the maximum strength. Okay, uh, and also if we talking about the yield strength, it is the maximum stress a material can understand withstand before it starting to deform permanently, and it makes the tensile from elastic deformation to plastic deformation. Okay. Also, if we talk the what is UTS, ultimate tensile strength, this is the maximum stress material can withstand before breaking when subjected to tension, and it represents the highest point of a stress and strain curve. This is the curve na. This stress strain curve. Okay, this is this way is strain and this way is stress. Okay, so this point, the ultimate strain point, this point is the maximum point. Okay, maximum point of the curve. So take it as a means a note that the ultimate strength is the maximum maximum means in the graph. Okay, maximum point. The factor of safety. So the factor of safety is the maximum point where after the fracture done. So this point the fracture will be means we will see the fracture. Okay, so breaking means fracture means break. So this is the factor of safety. So what is normal strain and shear strain? So you can see in the picture that if we uh, the normal strain, it will be acting in the change in length. Okay, if we applied force to this way, so this part of our means object will see the deform. So this part we will talk about the del t del l. The del l is means that change in length. Okay, and what is l0? L0 is original length. So this is the length the object was the previous, and del L is the length what is the after the force uh, the length happened, the final length. Okay, so what we can tell is del L by L0 is the normal strain. Okay, E means del L by del 0. What is shear strain? It is the the angular direction due to the shear stress. So here you can see there is an object, our object, this part is our object, and this dotted part is the object after means applying the force. So this angular deformation, okay, this angular deformation we can say the shear strain. Also we will talk this as a tan phi. Okay, but keep it as a reminder that normal strength which is applying in the change in length, and shear stress which is applied in a angular direction or angular distortion. Okay, so stress and strain relation. So first we can say in a elastic region, so stress is directly proportional to the strain. Here we can see stress is directly proportional to the E. Okay. Also, this E is Young's modulus. Young's modulus. So Young's modulus. What is Young's modulus? We will means understand in a different video. In a uh, only single video, Young's modulus. It is a very important thing. Okay. In the if we talk in this video, the video will be much longer. So we will talk in the youngest modular in a different video. So for now, and for now, the elastic region. Okay, so elastic region. This is the range the material temporarily deforms under the load, but return to its original shape when the load is removed, and it follows the Hooke's law. Okay, so uh, assuming that you have a rubber band, okay, you are increasing its, you are applying force and it is deforming to a in a larger shape. So why when you remove your load, it will be also coming back to its original shape, what was in before. Okay, so this is called the elastic region. Okay, now, and what is plastic region? You are applying force in the same rubber band you are taking. You are applying force, and you are applying much force than the elastic region. So at some point it means it will be the maximum deformation. Okay, so the part of the material stress and strains curve where the permanent deformation occurs after the yield point cross. What is yield point? Here it will be the yield point. This is the yield point. Okay, so after the yield point cross, and it is the region the material no longer returns to its original shape when the load removed. You are removing your load, but the it is not coming back to its original size. The first one size is not coming back. Like you are like means it increase in size. So okay, so this is the plastic region. Okay, and next coming to the fracture point, you are applying load in a much way. Okay, the what will happen to the rubber band? It will cut, it will cut like this. Okay, this part, something, this part will cut. Okay, so this point is, we can say that the fracture point or the failure point, this part. Okay, this part is the failure point. So um, you can you can say that the material breaks where under the extreme stress, or we can say that the point which is material breaks or separated. Your means rubber band is get separated by the stress or load. So this point is failure point. Okay, so this is the stress strain comparison. Here we are adding stress strain, and Young's modulus. Okay, so the internal force per unit area, it acts the stress. Deformation relative to the original dimension, this is strain. And Young's modulus, the stiffness of the material, we can call as the Young's modulus. The unit of the stress, we can say Pascal. The strain, we can take it as a dimension or ratio. This is the dimensionless. Okay, something means in ratio we can say the strain. And Young's modulus, we are telling at the Pascal. Okay, so thank you, engineers. Many thank you to see the video. Okay, and give us support. keep keep comment and like our video. Okay, subscribe to the channel. Thank you. Comment down below which topic you are wanting to for our upcoming videos. Okay, thank you very so much.